In Unit 4, one of our first topics is how to write ionic compounds. So one of the things we want to remember is we're going back and we're doing cations and anions. Remember, cations is another name for a positive ion, and an anion is another name for a negative ion. The idea for these is that when you have a compound, that there are balanced charges going on. So if you touch an ionic compound, you do not get shocked, because you are touching the same number of positives and negatives each time. Sometimes we're going to need some parentheses when we write our formulas, and we'll see that. A little shortcut from this is what we call the crisscross method that works most of the time, and we need to look at the situations where it doesn't work. And then finally, the naming of ionic compounds is the easiest part of this topic, because all it is the name of the positive ion and the name of the negative ion. So for example, this compound over here is called ammonium chromate because it's made out of the positive ion ammonium and the negative ion chromate. So it's just ammonium chromate. Here are a couple of examples of substances. I just found this really pretty picture on the internet. And we have like sodium chloride over here. Okay, and then this is an iron carbonate and an iron sulfate, copper sulfate, and I believe this is copper carbonate. And just different ionic compounds are all these little crystals, and some of these have colors because the positive ions are from the transition metals. Now, in class we did little cutouts to kind of get a visual representation of what's going on, and the idea here is that if we have something like a lithium ion, okay, the lithium ion has a positive 1 charge, and the oxide ion has a negative 2 charge. So we have lithium ions, we have oxide ions. And the idea is if we were to have a compound, we would have to be touching the same number of positives and negatives. So we can see what would happen is that 2 lithium ions, 2 positives, would match up with 2 negatives. So we made little cutouts. So for the oxide ion, it had 2 places. And for the lithium ions, each one has 1 place. And the idea is they would just fit together, and we can get that visual that we need 2 lithiums with every oxide. So the compound here, we can see, would just be lithium Li2O. So we have a couple things going on. We have these charges up here in the top, and we have these subscripts down here. So the subscripts represent atoms, and the charges represent, whether there's unbalanced number of electrons and protons. So when we start with 2 lithiums and an oxide, then we end up with Li2O, and that would be our compound. And again, the name is just lithium oxide, the name of the positive and the name of the negative. The fact that there's 2 of them, that's not part of the name. You just have to say lithium oxide, and the person who's writing that has to know how that goes together. Now, we have some other ions, our polyatomic ions, and I just want to mention you need to be a little bit careful here, because with the NH4+, CO3 2-, some people get confused and try to use those 4s and those 3s as part of their charges. And you have to remember that the NH4, those are all atoms, but it has a +1 charge. This has a -2 charge, -3 charge, -2 charge. That's the key thing we're looking at because we're trying to balance the charges. So again, this compound over here, this orange compound, is ammonium chromate. And so we have an ammonium ion that's got a plus charge. We have chromate with a -2 charge. So we're going to need 2 of these ammoniums in order to balance the charge on the chromate. So the plus and the plus together balance the -2. So this compound is going to end up being ammonium, and we need 2 of those, chromate. So ammonium chromate is this chemical. And now that I've just written that, I realize that's not even true. It's actually ammonium dichromate, but that doesn't change my problem. Now let's try some examples. I have cation, potassium, and bromide. Okay, so the positive ion and a negative ion. And again, we are only concentrating on the positive and the negative up there. Okay, that's not too big a deal here, but it's more when we get to here and we get to here. Okay, so remember, it's the charges that we are concerned with. So the -1, -2, -3, the -2, the -1, and these are all +1s. I'm going to clean this up a little bit. So we have a +1 and I have a -1. So how many cations will I need? Well, it's pretty obvious that one of these and one of these, those are going to balance each other. Now let's do the next one. If I have a +1 and a -2, then we can see I'm going to need 2 of my +1s to balance 1 of my -2s. If I take these two, again, we are only concentrating on the charge. So in this case, I'm going to need 1 and 1. Okay, so the 3 down here, the ClO3, that's not part of the charge. And the fourth one, I'm going to have +1 and -2. So you can see I'm going to need 2 pluses to balance 1 -2. So 2 potassiums will balance 1 carbonate. And the same thing here, the last one. This is -3, this is +1. And so I'm going to need 3 of these positives to balance my 1 -3. Now we want to notice something here, just kind of a trend, and that is what we call the crisscross method. So if this is 1 and 1, then I just need 1 and 1. If this is 1 and 2, I'm going to need 2 and 1. This again is 1 and 1, answer is 1 and 1. This is 1 and 2, then I need 2 and 1. 1 and 3, I need 3 and 1. Now the reason for this is the fact that all of the charges have to be balanced, but it does work out pretty nicely that if you just crisscross those charges, that'll turn into the number of cations and anions that you need. Now let's go back and write the formulas for these. If I have 1 potassium and 1 bromide, then I'm going to, you know what, I'm going to go and clean this page up a little bit. It's a little bit messy. And I'll say clear the ink. Okay, so I'm going to go back just really quickly and say I need 1 and 1. I need 2 and 1. I need 1 and 1. I need 2 and 1. And I need 3 and 1. Okay, so my first compound, if I just need 1 potassium and 1 bromide, then my formula is KBr. And the formula is called potassium bromide. If I need 2 potassiums, then I simply put a little subscript 2, and I have a sulfide, so that compound is potassium sulfide, K2S. If I need 1 and 1, I have 1 K and 1 ClO3, and the compound would be potassium chlorate. Now I had 2 potassiums and 1 carbonate, so it's just K2CO3, potassium carbonate. And my last one, potassium, I need 3, phosphate, I need 1, so K3PO4. And that's how that works. Let's try another set. Now this time, my positive ion is not quite so simple. It has several letters. It's a polyatomic ion. But again, we are just concentrating on the charges. So the 4 has nothing to do with it. It's just got a +1 charge. So I have 1 and 1, so I'm going to need 1 and 1. This one here is 1 and 2, so I'm going to need 2 and 1. 1 and 1, I'll need 1 and 1. Positive 1 minus 2, so I'm going to need 2 and 1. And 1 and 3, so I'm going to need 3 and 1. Now for my first one, I'm going to say ammonium bromide. I'll need NH4. We need 1 of those, and I need bromide. So my compound is ammonium bromide, and that's the formula. For the second one, I need 2 NH4s. So one thing that some people try to do is say N2H8, and we don't want to do that because we want to be able to see NH4 as part of our formula. We want to recognize that that's the ammonium ion, and if we write N2H8, then we can no longer really see that that's NH4. So we're going to go back, and what we're going to do is just say, well, I'm going to say NH4, and I need 2 of those, and I need a sulfide. Now the problem is here, it looks like what I've got is 42 hydrogens and 1 nitrogen, And we know that that is not what we want. So we're going to put in some parentheses. So what I really want are two NH4s, and that's what I have, NH4 in parentheses, 2, and a sulfur. And we would say that as ammonium taken twice sulfur, sulfide. So NH4 taken twice S, and the compound is ammonium sulfide. The next one is easy. We just need one ammonium and one chlorate. So it's impressive looking, but it's NH4ClO3. Ammonium carbonate, we need two ammoniums. So NH4 taken twice, CO3, ammonium carbonate, and ammonium phosphate, NH4 taken 3 times, and PO4. And that's how those compounds would work. Now, with our next set, some little funny things can happen. So the first one, here we have Hg2 with a 2+ charge. That's our mercurous or mercury 1 ion. And we have to keep that Hg2. So when we write our compounds this time, okay, we're going to say, well, 2+ charge and a 1- charge. So we're going to need 1 of our mercurous and 2 bromides. Now these ions are 2 and 2, and so we're going to need 1 and 1. Because a 2+ would match a 2-. So this is a place, and as other ones will, this is a place where the crisscross method doesn't work, because if you just say Hg2, you just think I need 2 and 2, so I need 2 and 2, that gives you the wrong answer, because a +2 will balance a -2. So if you see two charges like that, reduce them down to 1 and 1. So if you see two even numbers, two things that will reduce it when you get your cations and anions. Now the next one, we say we have a charge of 2 and a charge of 3, so we're going to need 3 of these and 2 of these. And we can kind of see what's going to happen. If I had Hg2, 2+, and I had PO4, 3-, that doesn't balance. So if I had another Hg2, 4+ and 3-, and if I had another Hg2, 2+, that would be 6+, and 6-, so 3 of these and 2 of these would balance out the charges. So when the charge is 2 and 3, then my answer ends up being 3 and 2. Crisscross method works very nicely there. Going back to here, we have aluminum 3+ and 3-, so the answer is not 3 and 3. A 3+ and a 3- will balance each other at 1 to 1. And 4 and 2, then those are going to balance out as I just need 2 of my carbonates to balance. So if I reduce my 4 and 2 to 2 and 1, then we get our crisscross answer, 1 and 2. Now let's just write in the formulas. 1 Hg2 is called Hg2, and I need 2 bromides, so it's Br2. And this compound, it looks like Hg2Br2. We might want to reduce, but we don't. We leave it just like that, Hg2Br2. In the second one, I have Hg2S. So it'd be mercurous sulfide or mercury 1 sulfide. And this first one would be mercurous bromide or mercury 1 bromide for the names. Okay, third one here, I need Hg2, but I need 3 of them. So I'll use my parentheses. We're not going to say Hg6 because that looks like 6 mercuric ions, but this is really 3 Hg2s. And I'm going to need 2 of my PO4s. And that's our compound. Kind of complicated, but that's right. Okay, the next one pretty easy. I just need 1 aluminum and 1 phosphate. And the last one I need 1 lead. Okay, and that's plumbic or lead 4, and 2 carbonates, so CO3, put it in parentheses. So if I have a lot of, if I have a polyatomic ion, like carbonate, phosphate, those guys, then if I need 2 or 3 or 4 of them, I'm going to use parentheses. If I only need 1 of them, I don't need parentheses. So that kind of thing will happen. So we've looked at cations and anions. We've lived through that. The idea is that we have to balance the charges. Once in a while, we need to use parentheses, and the crisscross method works most of the time as long as we reduce our numbers. And again, naming is very easy. All we have to do is take the name of the positive ion, name of the negative ion. And again, this guy here, okay, would be ammonium, and I'll do it correctly this time, dichromate, Cr2O7, 2 minus, and when those go together, I have a +1 and a -2, so I'm going to need 2 of my ammoniums and 1 dichromate, and the compound is ammonium dichromate. That's it.